So good morning one more time. So welcome to Apache Solar webinar by Edureka. So this session would be roughly around 10 minutes like that. So we will be covering the basics of Apache Solar. Why would one need to learn Apache Solar in this 1 hour session? So I'll be your presenter. It's me, Madan Kane. I've been working Apache Solar for quite a while now, so I'll be sharing my experience and knowledge with you guys so that you guys can take it forward. Okay? Fine. So before we getting into the details of what this course is all about, so I'll just briefly debriefing like what this course structure contains and what you could be getting out of this course. So this would be an 8-module, 4-week weekends. Every weekend you would have 2 classes. The starting batch is getting started on 1st of November, 7 to 10 a.m. IST. So we will be having all the live instructor-led classes conducted by industry expert on Apache Solar, and you can access all the content even after you go through the classes, and you can access all the recordings, the presentations, the lab content, and the material in the LMS for the lifetime. And you could also reach out to the support staff at any point of time if you have any questions, and it's a 24/7 support, and you'd have a lot of interactive material and content like quizzes, assignments, and project work. And at the end, you'll be provided with a certification after successful project completion. So this is the rough structure of the course, what we're going to introduce on Apache Solar. So if you have any further questions, you can always reach out to the support staff. Okay? Fine, so let's get on to the objectives. So what are we going to cover in the next hour or so? So basically we will be understanding the need of a search engine, what it is all about, why do we need a search engine, what are the objectives and challenges of building a search engine, and what is indexing, what is searching, why do we need to index data, and how we can achieve the indexing and searching in an efficient way. Then we would be talking about what is Lucene and what is Solar. So there is a reason behind why we'll be talking about Lucene in the Apache Solar course, so we'll be covering that in a short, and also we'll be debriefing some of the Solar and Lucene features and its architecture, and then we'll be winding up with a small demonstration of Solar and ending up with any Q&A. Okay? Does that sound good, guys, for everyone? Yes, no? Fine. So before getting into the details, just a quick overview of one of the famous e-commerce portals in India, Flipkart. So you might have seen more or less these kind of portals serving with the search results by typing in the keywords or search engine kind of feature, right? So how many of you are aware of this kind of application? I hope most of you would have seen the search aspect of any e-commerce, like a hotel booking, like booking.com or Expedia or Amazon or eBay, right? So everyone, there is one common thing what you would have noticed, the search box, right? So the search box which you see at the top of the any e-commerce portal, you see anyone can type in what they are looking for and hit the search button or enter key. You'll be provided with all the results matching your search term or matching your word what you're looking for. So this is the basic search feature which any e-commerce or enterprise applications nowadays require to incorporate into their applications. So this is exactly what we'll be learning, how to build an enterprise or a web scale search platform for this kind of applications. Okay, so on your left hand side you might see a category like price, brand, operating system, all these kind of stuff, right? So again, when you do the search application, there could be a lot of cross-functional aspects or features which you would require. So in this case, if someone wanted to filter out based on price, based on brand, based on operating system, so you have to have some sort of a mechanism to do that. Again, you need to have a search engine doing all these kind of features. So we'll be talking about what exactly these are and how to achieve this kind of functionality and how to build an application, web scale application using Apache Solr. So that's the whole idea behind having Apache Solr and integrating Apache Solr for enterprise applications. Okay. Fine. So let's try to understand what is Lucene. So even before we get into the Solr, we have to understand a little bit of what is Lucene. The reason why we are touch basing Lucene is because Solr has been built on top of Lucene. Most of the features and most of the aspects which has been expanded or derived from Lucene. So it is always good for us to touch base what is Lucene so that we build a grounds up knowledge base and we understand what is Lucene, and if required any fine tuning we can go to the core library itself where we can work with on top of Solr. So Lucene is a very powerful search library built in Java. So you might have guys have noticed this guy, Duck Cutting, very famous guy, built a lot of other frameworks. Any cases, any other frameworks which you guys are aware of? Anyone? Great. Yeah, thank you, Sam. Thanks for helping. Thanks, Kaushik. Yes, so he's the guy who has developed Hadoop as well. So again, he has built the Lucene Java library, which will enable you to build the kind of features what we were talking in the previous slide. So it lets you build a very powerful search platform, and using those APIs you can index the content and retrieve the content in much more efficient way. Okay, when we say much more efficient way, the first question comes into our thoughts is, why not use a database? Yes, absolutely, we could have used databases. The reason why we could not use databases to scale huge enterprise applications, I'll be debriefing it in a while. So let's assume I have a table in a database and I have to search on the table on some of the fields. Let's say I have an employee table. Okay. Let's say I have an employee table and I have employee ID as a column, name as a column, address as a column, city as a column, and say phone. And let's say I have say 100,000 records. And if I wanted to search for employee, which I vaguely remember what is the employee's name. I don't know the exact first name, last name, or the middle name. I vaguely remember maybe the employee was Sam, right? So what I can do is I can write a query, something like this, right? Employee, where, name, like, and then we start the ampersand and I can say Sam. Right, guys? So what happens here is, say if you write something like this, it has to go and search each and every row in the table, and then in that column of name it has to go and scan for the characters in between the name for each and every row and column. Say let's put more complexity to it. Let's say, okay, I don't know exactly the name, okay, but I also don't know the exact address. I vaguely remember he's Sam, and he may be staying somewhere in an area called DC Halli or something, right? And I vaguely remember his phone number is ending with 324, something like that. So what happens here is now you have to write a similar query with more number of columns associated in the like clause and keep on searching, or put the something like this, name like, right, or address then like. So this kind of operation becomes expensive and heavier as the number of records keeps on growing, because every time it has to go and have to do a full table scan and search for all those things. So with roughly say 10 million records, it may even the most powerful hardware you have, it may take up to few seconds to fetch these results back. So what people would have thought is, okay, why don't we create some index on these columns? Absolutely, you can go ahead and create some index on the column, name column, address column, or city column. Even after creating the indexes, since there is a lot of characters which is embedded, right, you don't know how to index the embedded characters. You can only create the lexicographical order of the column values, and the more indexes you create on the bigger tables, again re-indexing for every update is also going to be a bigger problem. So the databases is not the right solution, or it is not the appropriate structure to be used in case of heavy applications which has a lot of records. So that was the reason why people thought there has to be some alternative like Lucene, where there is a better way of storing the content and retrieving the content by using the indexing and searching techniques, which we'll be covering it very soon. Is that clear, guys, why we would need something like Lucene or Solr to build a search platform? Yeah, so Amit says any search engine uses the databases. Absolutely no. If there is huge web applications, nowadays 99.99% everyone use Solr or similar technologies like Elasticsearch or Solr. Everything is built on top of Lucene. So anyone who has like say only 1,000 to 2,000 records, they don't have to go ahead and build something like Solr. They might be using something, a very simple database and select clause kind of a thing. Absolutely. So we'll be covering all those. Jaideep has already catched the idea of caching the content in memory and searching on that. Something similar to it I'll be explaining today in brief, and in the course we'll be covering all of them in detail. Okay, so that was the reason why we wanted to have an alternative, and Doug Cutting thought about it, that need, and he captured the idea of building a Lucene library, which is a very powerful and scalable API library which can be used for building search applications. Okay, and also it is 100% pure Java and open source, so you don't have to buy anything including Solr. It is open source, you have to just use them, that's it. Okay, and also if you guys are concerned about, if you guys are not familiar with Java, how do I adapt Lucene or Solr? For understanding Lucene, you don't have to know the details of Java, but it is good to know Java because we'll be covering Lucene in the couple of modules, and it is always good that you know Java. But Lucene also has implementations in numerous other languages, say from C#, .NET or PHP or other languages. Also you can adapt Lucene or Solr. Fine. So just now I've explained about why do we have to use a library like Lucene. So any guesses by this time, what are the two top things any search library or a platform has to accomplish? I've been mentioning these two keywords all along. Any guesses, guys? So I wanted to make it a little bit more interactive. Exactly. So Sam says indexing. That's one key aspect. What is the other key aspect? Anyone else, guys? Quickly. The other key aspect is searching. No worries. So these are the two key aspects which any API library has to focus on: indexing and searching. So there has to be a different way of indexing the data, and there has to be a different way of searching the data what has been indexed. So these are the two key things which we will be covering in detail across the course. What are the different ways of indexing, and how does the indexing happen, what you can fine-tune, what you can control, all those aspects. Okay, so we have spoken about the database indexing as well. So people might question, so what is wrong with the database indexing? Okay, so most of the databases uses B-tree for the indexing techniques. B-trees is nothing but a binary tree which has the lexicographical ordering of the column data. Okay, so as I mentioned, B-trees gets more inefficient in case of data or a character tokens which you have to search, embedded tokens or embedded characters which you have to search, because B-trees are only ordering the full value of the columns. It is not splitting, or it is not tokenizing the inside value of the column, right? So it is just only ordering all the column data, but it is not tokenizing the column data. That's the first reason. And second reason is the B-tree indexing itself is not efficient because it cannot handle the volume of indexing data indexes, and it will be very inefficient way of doing it in the databases. Okay, the question arises is, what is this all B-tree? What is this indexing, first of all? So how many of you have seen indexes on the backside of the book? Maybe everyone, right? Can anyone quickly explain me, why do you use index, the book index at the back of the book? Can anyone quickly explain me, why do you need, or why do you use? Exactly. Absolutely. So you guys are really fast and quick to catch it. So what we do with the back of the book index is, say for example, I'm searching for a particular term or a word. I don't have to read the entire book every time to find exactly where that topic is all about, right? All I do is quickly surf through the back of the index. The back of the index is again lexicographically ordered from A to Z, or from 0 to 10 and then followed by A to Z. Then you can find the word what you're looking for, and then go to that page and retrieve the page and read what you're looking for, right? This is the exact technique what Lucene or Solr has adapted. To be very precise, what Lucene has adapted, because Solr has been built on top of Lucene, and Solr is nothing but just a web wrapper for Lucene. So Lucene adapted the exact technique of the book index. So this is the most efficient and the fastest way of using or searching the content. So somehow if we can index all our documents and all our tokens in some form of index lookup, then we can easily go ahead and retrieve the information much more faster and easier way. So now we guys are clear on why we need indexing. If you had only few records, right? If you had only few records, you might have not required, say, 10 documents. You might not need an index, because all you need is every time just go and look those 10 documents or 10 pages. So it would be easier for you to surf through those 10 pages. So if you have, say, 10,000 pages or 10,000 documents, you always prefer to have something like a indexed lookups where you can go and find that content. Right, guys? Yes, Prasad, there is a recording which will be provisioned for anyone who can view this offline, so you can always take a look at it. Okay? No worries. So you have not missed a lot. So we have just started. Fine. So since we have seen what is indexing, what is the need of an index kind of a structure, so we'll see what exactly the indexing process consists of. Okay. So indexing is nothing but series of steps, very simple steps, which you can think of in a very layman terms. So first thing is you have a document. A document is nothing but a record. You can also correlate with the database terminology. It is a record. So in Solr or Lucene lingo, we call it as a document. Okay, a document can consist of various information, just like a record can contain fields. A document also can contain fields or columns, and you can represent the document either in XML or JSON or whatever format, a plain text, anything, a content or a piece of information, we can call it as a document. So once you have the document, you can submit the document for analysis. Okay, so that is the first step what happens in Lucene. So you guys might be wondering, what is this analysis all about? Okay, so when you submit the document, the analysis part understands what kind of documents it has, what kind of fields it has, and how to understand and split or how to parse that document. So for example, if you give a XML document to Lucene, there has to be some sort of an analyzer, first pre-processor, which understands what are the XML nodes or what are the XML elements you are submitting. Okay, what type of fields are there? Is it a numeric field? Is it a string field? Is it a binary content? All that stuff has to be analyzed upfront. So this is the first step what happens in the analysis. Once the analysis is done, then the next step is the tokenization aspect of it. Okay, so Sam has a very good question. Do the documents should be in the same format or any loosely structured data can be analyzed? Great question, Sam. So the beauty of Lucene or Solr is it does not impose any global fixed structures. So it is very flexible. Any loosely structured data from HTML documents, from web links to say from PDF documents to Word documents, anything can be indexed and anything can be searched. So everything can be analyzed and tokenized and searched. Okay? Fine. So the next process is tokenization. So what does tokenization mean? If you think of a document is nothing but for Lucene just a stream of text or a stream of words or stream of tokens. In Lucene or Solr terminology, a piece of word or one word is called as token. A list of words or stream of words is called as tokens. Okay, so that is the Lucene terminology. So let's get acquainted with all these terminologies so that we will be using this as tokens or terms moving forward in the course as well. So the next piece is how to split the stream of text into tokens, because the way Lucene handles the indexing is using the term vectors or the bit vectors, what we call it as. So if you see the bottom portion of the slide, you'll see there is a stream of text. In this case, the document just only contains a Edureka Hadoop. When we submit this to the tokenization process, so the first thing what happens is it splits the words into two, Edureka and Hadoop. So now you have two terms. One term or token is Edureka and the other one is Hadoop. So then Edureka, it says, okay, which document this term is pointing to, what is the offset or the position, what is the length of the term. So this is kind of a first level lookup into the index. The tokenization splits all the tokens into term vectors and stores the term vectors. So when someone is looking for Edureka, the first lookup happens into the term vector and it finds out where in the index you can find this particular document where you can return it back easily. Okay, so this is the very high level flow. The more and more we spend time on this, you guys will be able to understand this pretty clearly. Okay, fine guys. Okay, so let's briefly touch base about what happens in the Lucene when we try to write a document or update a document into the index. So as I mentioned, a document can contain multiple fields. So a document will be submitted to an analyzer. There will be a component or a piece. There will be a component or a piece what we discussed called analyzer. Analyzer consists of tokenization and lot of filters, and then it gets submitted to the component called index writer. So once you have all the term vectors and the tokenization has been done, the term vectors is given to the index writer and it goes and updates the index or the directory. Okay, so meanwhile Sam has a another great question. So how does it work for audio, video or image files? Great, Sam. Fine, so this is a bit tricky. So Lucene does not understand first of all what kind of a document it is. Okay, for Lucene everything is stream of tokens or stream of text or binary content, period. So Lucene does not treat or understand whether it is an image document or it is a kind of a video file. No, Lucene does not understand anything of that. We have to use lot of other libraries or techniques which we'll be covering in the course in detail. Say for example PDF. Let's take a very simple example of PDF. Audio, video, image is much more complicated content to handle. Let's take a PDF. Even PDF is a very binary rich file. If you open a PDF file, you'll not see the content what you would usually see in a text file. You'll see a lot of binary content in it. For that, you have to use a library called Apache Ticker, so that using that kind of libraries or Solar Cell framework, you can extract only the content and discard the binary portion of it. Similarly, you have to use something like say for example you have a video file where you wanted to capture all the captions. Okay, so there are a lot of libraries, so you have to extract all those things using a external library. Lucene does not understand what file, how to manage or how to process. Okay, sir, so we'll get into all the details while we get into it. And also Amit has another question. I think analysis is the most difficult part. You are absolutely right, because once you understand the analysis, what are the various flavors of analysis and how you can customize, how you can control analysis, you'll be the expert of Solar or Lucene. Okay, so that's the intent, that we'll be covering as much as possible, and you will be practicing as much as possible on the analysis and the analyzers part of it. So Prasanna has a question. So will Apache Solar run on Windows machine or should be Linux and Mac machine only? Great. So as I mentioned, it is purely written on Java. So you don't have to worry about the interoperability of this platform, either Lucene or either Solar. So can you quickly answer me, Prasanna, since it is written on Java, if you install a JDK or a JVM on your any Windows PC or a Mac or a Linux, you should be able to run on top of it, right? So just in case if you are aware of JDK or Java, so you don't, in straight terms, you don't have to worry about whether it has to be Windows, Mac or Linux. It should run on any machine for that matter. Okay. Okay, guys. So just a moment, guys. I'm just pausing it for a second. Fine. So since we have seen what it takes for us to index the data, it's always important for us to understand the other side of the aspect which I mentioned is very key, is the searching aspect of it. So the data, whatever we have stored it in the indexed format, right, we also have to retrieve that information, right, for our application needs. So there are a couple of approaches you can retrieve that information. In the Lucene world, which we will be sticking to purely on Lucene, we can either write the APIs to retrieve the information or use something like SQL. Say for example, we have seen this example, right? Select star from table. You can use something like similar to that. What we call it as Lucene query syntax. Using Lucene query syntax, you can write queries to retrieve the information so that you don't have to worry about the complex APIs or Java APIs, all that complicated things. Yes, if you wanted to have much more granular control, you can always go back to the APIs, but expression language, what we call it as Lucene query syntax, also provides you the complex mechanisms to retrieve all the information the way you wanted it. Okay, so meanwhile Sam has a question, where does the indexed info gets stored? Great. So all the databases, Lucene or Solr is also treated as a NoSQL database, which will be covering it. Eventually it has to be stored in some sort of files in the disk. Okay, so all the indexed data, what we call it as, I'll show you just to be a little bit more precise. Okay, let's say this is the one of the labs which you will be covering in Lucene course. Okay, so this is the indexed data. These are the exact database files which will be written onto your hard disk. Okay. So Srinivas says, could you please give me a small brief about web crawling and how is it related to Lucene or Solr? Great. In fact, by terminology, they are more or less similar. When I say by terminology or approach, they are similar. When you talk about web crawlers, the popular web crawlers like Google or Bing or Yahoo, they use little bit more advanced platform and searching techniques. So Lucene or Solr may not be the right choice for them because they do extensive study of the web information which is in billions of pages. They have to do an extensive analytical study rather than directly doing a blind index and retrieving the information and giving it back to them. First thing. Okay, so if someone just wants to index all the web pages and retrieve all the web pages based on some search criteria or some face setting, yes, Lucene or Solr would serve the purpose. But if you notice Google does a lot of intelligent thing while doing the web crawling. It understands what are the page weights, what should be the top searches coming in the first page. All those intelligent things are completely different. Okay, so that way the approach, you can use Lucene or Solr to do the web crawling just as your fun project. Okay, you can just give all the links. Lucene will index all the content or Solr will index all the content and you can search all the web pages. It will be a fun project for you. Okay, so that's how it is a little bit different. We can get into all the details of it. The more and more we keep exploring, we will be able to follow that, Amit. Since with the short time what we have got, I'm just limiting the scope of discussion to that. Okay, so Srinivas and Amit says it is not that it is only Lucene is for mid-sized companies. So how many of you have seen Yahoo or Amazon? Let's take Yahoo. Yahoo portals. Yahoo, all of the Yahoo portals is like billions of pages, uses Solr and Lucene in the backend. So it is not for mid-sized companies, it is for different purpose altogether. If you are building something like a search engine like Google or Bing or some other search engine, then Lucene is not the right choice. If you're building searching within your organized data, then Lucene and Solr is the right thing. It is not that Lucene cannot scale for bigger companies. Yes, absolutely it can scale for bigger companies, but for different purpose altogether. Okay, so Srinivas had a similar question. Lucene or Solr is best fit when I wanted to search on a specific e-commerce site. Great question, Srinivas. Again, it is not restricted or mapped to that it has always to be used in e-commerce site. No, absolutely not that way. Say for example, if there are a lot of enterprise applications, right? Whatever I am aware of, all the enterprise applications, the CRM applications or the content management applications, most of the applications, they also use Solr and Lucene. It is not that just it has to be ERP application. So any application where you see a search text box, that's the reason in the first slide I showed you, anywhere you see this thing, you should say I'm going to use Solr. That's a first thumb rule. Let me show you this. Anywhere you see this, the first thing is anywhere you see this search text box, okay, it could be anything. It could be YouTube, it could be anything. So the first thumb rule is anywhere I see this, you should think of Solr or Lucene or any platform which is built on top of Lucene kind of a search library or a search platform. Okay. Fine. So let's quickly understand what is the technique or the flow, what happens in the Lucene indexing process. So if you see on the top side, these are all the documents. The top, let me just pull out. One moment guys, I'm just saying if I can, okay, drawer, okay, I cannot, fine, no worries. So these are the documents which gets stored in the index, okay. Lucene uses a technique called inverted index, okay. So index is a simple one. If you just use the book approach of storing all the indexes at the back side of the book, okay, and invert the process of having that index into a small lookup in very short, that's what we call it as inverted index. So don't get worried, it seems to be a bit confusing in the first term. I'll try to explain it in brief right away. Let's say I am adding all the documents and I wanted to store it in an efficient way. So the first thing is, instead of going and storing all the data and having lookup for all the documents, what I can do is I can create segments, okay. So the segments will remember, so the first segment will hold chunk of indexed documents or records, and segment 2 can hold segment of other records, and then I can keep on creating segments. Say for example, if I wanted to look or do a lookup for a term or a document, instead of going and searching all the term vectors, I know exactly where I can locate a group of terms itself, right? So it is like lookup of lookup, so that you can have multiple lookups and you can ease the speed of search as well if you have large set of documents. That's one way of thinking, one way of looking into it. The second is, say for example, as I mentioned, the indexing technique is a very expensive and costly operation if you are updating the documents very frequently, irrespective of whether it is a database or Lucene or Solr. It is a very costly or expensive operation. The reason why it is very costly or expensive operation is, say for example, every time you add few bunch of records, the entire index structure has to be reshuffled. So if you have millions of records, shuffling the entire index structure is not going to be that easier if we don't follow a proper technique. That's why Lucene adapts something called merge sort and using segments to merge the index while the updates are happening. What a merge sort does is, in this case, instead of directly going and reshuffling the entire index for every update, it creates a local segment. Okay, so say for example, now you have updated 5 new documents. So it creates a local segment like a local index, which is not primarily associated with the primary index. So any new documents between that threshold will be created within that local segment. Okay, once that threshold, say 100 documents is your segment threshold, it crosses that threshold, it goes and merges the entire with the entire index. Okay, so that is that you don't have to worry about updating the index every time. It accumulates some, after it fills the threshold, it goes and merges the segment into the bigger index. So that way we are not doing the merge operation very often, we are just accumulating. The second thing is, using this approach, it is also faster to read and update information. We have seen how it is faster, but when you are reading, you may have to go ahead and read from the local segment as well as the global segments, so that you are reading from the content which you have updated the most recently. Okay, so this technique we can explore it more in detail. This is what exactly Lucene does, which we call it as a inverted indexing technique. So Srinivaslu says, can thresholds be age of the documents based? Absolutely. So if you just look at the thresholds, so most of the time the thresholds is not just the age of the documents, it is also based on the volume of the documents. Say for example, if you have only updated one documents, it could be accumulation of both. In the last 5 minutes, it may not be necessary for you to just go and update that one document. Okay, if your threshold is accumulation of time and volume, yes, then it will, then there are a lot of intelligent algorithms which will figure out, okay, now it has crossed the time threshold and the volume threshold, it's time to flush and merge and sort the bigger into the bigger index. Okay, so it could be based on both as well. Okay. Fine. So as I mentioned, Lucene or Solr does not confine or restrict you to follow a very rigid schema like databases. It is very flexible. It has a very loosely coupled or loosely defined schema, which is very simple. For us, it could be just documents. In index, it can have multiple documents, and each document can have multiple fields, and every document can have different fields. It's not that you have to have all the same fields in every document. Say document 1 can have field 1, 2, 3, 2 can have completely different set of fields, and document 3 can have no fields at all. So it is absolutely flexible. There are no restrictions that you should have all these fields like databases or you store null. No, there is no such constraints or such restrictions. So as I said, it is very loosely defined and it is very flexible that you can use your own structure or schema for it. Okay, so as you guys rightly pointed out, the most important aspect so far you guys have figured out that the analyzation part of it. So we'll be spending more and more time in understanding analyzers in the course as well. So as you see, the analyzers consists of one tokenizer, at least one tokenizer, and series of filters. So the output of the analyzer, if you guys have noticed, during the session, it should be stream of tokens or term vectors. Okay, and the input for the analyzer is a reader object or stream of text or string object which can be passed, and the output will be tokens. So there are lot of analyzers with lot of tokenization options, how to treat CSV file, how to treat XML file, what are the different ways of filters. So this is the most important and interesting aspect in Lucene and Solr, which we have to understand in detail. The moment you understand in detail, you can become a very good Solr or Lucene developer, and you can become an expert. Okay, our course also focuses lot of time in understanding the analysis as well. Just to give a debrief of what you can expect, I can show you. There are like only on few things I can show you the code what we'll be working on, just to make it a little bit more interesting rather than looking into all the code aspects. So we'll be looking into each and every analyzer, how it performs, what kind of filters it can have. Okay, we'll be building our own analyzers as well, right? See, we'll be building our own analyzers, what kind of filters I can use in my analyzers. We'll be covering all these things in the class. Okay, so there are a lot of filters. We'll be using each and every filter. We'll be building our own analyzer. We'll be using the analyzers and the filters what has been provided with the inbuilt Solr and Lucene as well. Okay, so this is the most important aspect, as you guys are figured out. Just to give you a snapshot of, this is not the complete list, just some examples of analyzers what you can see. Analyzer, say for example, should understand each and every language. So it is not always that you will be using English as a standard language to analyze and store documents. There could be all different languages. So Lucene and Solr has a complete list of internationalized language set which it can understand, analyze, and index the content. So we'll be covering all of them, along with there are ample number of analyzers and filters. I cannot fit in all those things in this slide, so I've just shown you a glimpse of what it could be all about. Okay, fine. So since we have seen what kind of analysis needs to be done, so there are various ways or the features which Lucene supports, or Lucene supports to retrieve the information. So we'll be seeing all those different aspects, like how to join Boolean queries, how to do phrase querying, how to do wildcard searches, how to do a fuzzy query, how to search documents based on numeric ranges like date ranges or birth date ranges. All these things will be covered in detail when we take the classes. I'm just trying to provide all the key class types. So similarly, if you notice, I'll be showing you, these are all some of the queries which we'll be covering in the class. We'll be walking through all the classes and everything, so no worries. So I'm not going to cover all those things here. I'm just debriefing what exactly is going to come. Okay, so we'll be covering most of these aspects in the course, the different ways of retrieving the information using the key classes or APIs provided by Lucene. Okay, fine. So we'll also quickly understand what is scoring or boosting. Scoring or boosting is nothing but if you wanted to give some sort of weightages. So you might have noticed on Google or on in some places the paid ads, right? So a simple technique, what happens is, if say for example, if someone wants to put their ad or document on top of the search results and they're paying for you to put that, so what you can do is basically you can go ahead and put some weightage to it, okay, and push the records in the order. Okay, so Lucene returns all the documents in a lexical sorted order. If you wanted to boost a particular record based on the search term, you can always do that using the score boosting. So the score boosting, which we'll cover in detail in the class, can be done in two places. One is while we are doing the indexing or while we retrieve the information. Okay. Meanwhile, Surendra is curious to know, can you give me an example of custom analyzer which you used? Yeah, so we'll be covering all those things, Surendra, in the classes. So the custom analyzer is nothing but I can use n number of filters, any tokenizer. So we'll be covering like how to build a custom analyzer using my own filters, my own tokenization. So that is what a customized analyzer would look like. Okay, we'll cover all those things in detail, no worries. So some of the features what you can expect in Lucene is faceting. Faceting is nothing but it's a type of grouping but with the facet counts, which I've shown it in the first slide. On the left hand side you might have noticed grouping based on a particular category or term and count to next of it. Say for example, you might have noticed the brand price ranges, all those aspects is called as faceting. Okay, so the highlighting is nothing but, say for example, if you have searched for say Sony camera or something like that, so in the search results you would have noticed in most of the websites it would have highlighted that component or highlighted the term what you have searched in the documents. That is what we call it as highlighting. Similarly, all the grouping, joins, spatial search. Spatial search is another important aspect when you have to deal with the geographical maps or something like lat-long, search based on the geolocations or on maps. Spatial search is very important. As I mentioned, Apache Ticker is used to parse the rich documents like PDF, Word documents, Excels, all those kind of things. Okay. Fine. So since we have covered some of the basics of Lucene, so I'll be covering very high-level aspects of Solar as well. So I hope we may get extended for another 10 minutes. I hope it should be fine with you guys because I thought of giving a bit more description rather than what I thought it would be very high-level summary kind of a thing. So if it is fine with you guys, yeah, thanks, Sam. So I'll be taking a little bit more time, another extending 10 to 15 minutes. So please bear with me. Those who wanted to drop can always listen back to the recording as well. Fine. So we have seen what is Lucene, but our course is primarily focused on Solar. So the reason why we have to have something like Solar is so not everyone will be comfortable in working with the Java APIs or any other APIs, writing the code, understanding the code, fine-tuning the code, fine-tuning the analyzers and all that stuff, right? So how many of you would like to go ahead and do something hard coding like this, writing hundreds of lines of code for a small feature, or would you prefer a web service API, something like this, okay, where I can just go and query using the simple HTTP URLs and get all the data what I want, or index the data what I want. Which one you guys would prefer? Absolutely, the second one. So that's the reason why Solar has evolved. So instead of dealing the nitty-gritties of dealing with the raw API, you can always work with an interface which is much more easier and faster to develop search applications. Solar is nothing but a web application using Lucene API libraries. It's a very simple web application. You can access the content and update the content using the REST URLs, REST APIs or URLs, as simple as that. Okay. So before proceeding further, Praveen says, how is the market on this? So what I would tell you is solar was a niche skill and a niche uh, technology which has been used by limited set of companies in the last 4 to 5 years. With the new version Solar 4 and 5 in the pipeline, Solar 4 is no more treated as a technology or just a web application. It is treated as a NoSQL search capable database. So think of big database, NoSQL capable have handling big data, and provided on top of that it can also scale for search needs. So that is how Solar is heading towards. With Solar 5 you will see there is a drastic changes from the initial versions. So now today everyone can use Solar for near real-time reads and updates. So that's the change or the transformation what is happening in the Solar. The second aspect coming to the market dynamics. So everyone, whatever I came across, 95% of the companies are trying to use Solar for some or the other needs in any enterprise applications. If someone is not yet started using it, you guys should go ahead and recommend and say use Solar. This is much more faster than databases if you're searching for the content. Okay, very simple. So Amit also has a question: is Eclipse for Java Lucene API is for as Eclipse is for Java Lucene API? Yeah, something like that. I was not very sure that I understood your question, Amit. I'll just park that question. Maybe we can come back to the later part of it. Okay. So as I mentioned, Solar is nothing but a simple web application built on top of the Lucene Search APIs, and it provides RESTful APIs via XML, JSON, or CSV interfaces. So you can also choose to interact with Lucene using Solar, XML or JSON or CSV formats. Okay. Jaideep meanwhile says, how is the migration of data from existing databases to Solar possible? Absolutely possible. It's a great question, Jaideep. So there are a lot of import handlers which you can use to import and trigger the updates happening from the databases, which Solar provides inbuilt. So using a database import handler, you can retrieve all the information, and also thereafter all the delta can also be triggered and pulled into Solar. So all those things can be done, which we'll be covering in the course in detail, not at least in this session. Okay, so I'll not cover this slide, just to give, not to take away the credit. So Yannick was the guy who started to build a web application in CNET using Lucene API, so that credit has to be given to him. So I'm just briefly talking about it. There are a lot of significant changes what happened in Solar from the initial stages. I'll be covering all of those details. What was the drastic change in the architecture design? That was the reason why people started adapting very aggressively. So today every organization is looking to use some sort of a Solar feature which is built on top of Lucene or Solar. So my take, it is really a good one to keep it handy in our skill set. Okay, so Solar is just an extension or a wrapper of Lucene, plus it has also added few more features. So whatever Lucene provides, Solar provides the same thing. Additional to it, it also adds a lot of features on top of it. Like you can have all the interfaces based on REST APIs, XML, JSON, and HTTP. There are a lot of comprehensive admin tools, monitoring, logging tools, and a lot of components which you can use it for near real-time indexing. Just a few of them I can show it to you guys. So this is one of the tools which you can use to query the information or to retrieve the information or to update the information or to interact with the Solar database itself. Okay, so just to show you guys, let me search something in the name called Sony. Let's see if there is something on the name Sony. Okay, there is nothing on the name Sony. let's say something like enterprise. Let's say if there is a token or a document in my thing. Yes, there is a document called enterprise. Okay. So this is the interface which we'll be using throughout our course. Is provided by inbuilt Solar. This is the admin tool. There is a hell lot of features, hell lot of sections in the dashboard, logging, how to configure the logging, how to configure the core properties of the instances, all those aspects which will not be touch basing. I just wanted to showcase. These are all the additional features or the tools what you get on top of Lucene. Apart from that, you can also control the entire Solar instance using the administrative console as well. Okay. So again, Surendra, if you notice, I've shown you the index folder on Lucene. If you remember, it is stored on the file system, right? So Solar doesn't do anything. Here is the files, actually how it gets stored. But if you use Lucene, these are all the Lucene database files. Okay, Solar doesn't do anything. Rather, what it does is it takes the request from you, okay, and calls the Lucene APIs in the backend. Internally, it calls the Lucene APIs, and Lucene APIs handles all the information retrieval and information storage. And as I mentioned earlier, Lucene stores all the data in the file system wherever you configure the path of the index. Okay. So we will understand in a distributed Solar environment how and what is the architecture and all in detail. The content is stored, how it is being retrieved, all that stuff, which is much more interesting. Okay. So just a brief architecture. I'll not go through each and every component. There are a lot of components which frames the architecture of the Solar, like say request handlers, request writers, update handlers. I'll briefly talk about some of these things. Say a request handler is nothing but the component which you are interacting with in the Solar. So in our case, I'll just quickly show you something. So this is the request handler. This is the component /select which I am interacting with. This is one of the components or the request handlers which we can interact with. Similarly, there will be a lot of other similar request handlers. I've just mentioned few of them like admin, spell, and there could be a lot of other components as well. The request writers, it could be of XML, JSON or binary. It means the response writers, and also the update handlers, like you can update or interact the content using XML, CSV or binary or JSON format as well. Okay. So all these request handlers, the next level, it uses some of the search components. Okay. Based on your search, it may use one or more search components. Okay. So once you have submitted your request to the request handler, it uses different search components and the underlying distributed search. So for a large scale enterprise or application, one Solar instance or one server may not be sufficient to store the billions of records. So you need to have a distributed search. Solar is capable of handling distributed search. We'll talk about that in the course, as well as briefly today how the replication happens, how the data sharding happens, how the failover techniques happens, all of those aspects. Okay. So once it passes all that stages, the later part is the index writing and the reading part of it, which is the core Apache Lucene. So these are the same Apache Lucene framework which is being used by Solar, and Solar has so many other components which provides the flexibility and ease of interacting with the application. So this is the overall architecture, which will not go into the details of it at this point of time. So Sam has a very interesting question. So does it use HDFS for storage? No, it does not use HDFS. It uses plain, straightforward file system like any other databases, but it can also be integrated with HDFS. Okay, we'll talk about, without using HDFS, how to achieve the scalability, how to achieve the failover, all those things. Okay. So this is the admin UI, which I think I've just briefly shown it to you. I'll not stop by this. Okay. So there are a lot of things what Solar does. Just think of a web application as one instance or one server. Okay. So every server or an instance can have multiple indexes. Okay, so Solar can handle multiple indexes, which we call it as cores. In one server you can have multiple index. Index is nothing but an instance of a database. That's what we call it as. And each database or instance of a database can contain group of documents, and each document can contain all the fields. Okay, so if you notice, the entire index is controlled by using a XML configuration file called schema.xml, which will be covering in detail all of these configurations. The beauty of Solar is that you don't have to deal even with a single piece of code. All you have to do is control all your aspects, the fields, documents, the search components, the analyzers, the tokenization, everything in the configuration files. Okay, XML configuration files. We'll talk about all the detailed XML configuration files, what and all we have to deal with in the course, as well as we'll just briefly touch base. Okay, so as I mentioned, Solar Core is nothing but an index which is part of the instance of the Solar. Okay, so each index or core can have schema.xml and Solar config.xml. So schema defines the structure and the field types, and Solar config.xml defines the search components, the analyzers, the tokenizers, what and all you can use and what you are using. That is the aspect of it. A single Solar application or server can contain 0 or more cores. Okay, a core is nothing but, in our case, this is the core or a collection. This is collection 1. This is the core. Okay, if we wanted to create another core, we can absolutely do that, and we can have a number of instances based on your design and based on your need and requirements. Okay, fine. Just to give you a glimpse of how the docs would look like. So in XML format, this is exactly how it would look like. The document fields, so it can have any number of fields. It's as flexible as what you could think of. Okay. So similarly, what we have seen in Lucene wanted everything interacting through APIs. So Solar can interact everything through HTTP requests on REST APIs, either in XML, JSON or CSV or other formats. There are a few other formats which Solar can understand. So all of these formats can be interacted to index the data into Solar. So by now, I think this step or this slide should be much more familiar. So in Lucene, we would have to write the analyzers or configure the analyzers using the APIs or the code. In Solar, you have to do all of these things using what, guys? Can anyone quickly explain? Quick check. How do I define analyzers, tokenizers, filters in Solar? Using? Guys? Yes, config files, which we just spoke, touch base, Solar config XML files. Okay. Fine. So let's quickly see how does the search process is handled by Solar. So when a search is submitted, so as we have seen in the architecture as well, the first component which comes is the request handler. In our case, we were using select. So our request is submitted from the HTTP to the request handler, and the request handler takes care of parsing all the data and then passing it, the query, to the query parser. A query parser is nothing but based on which type query parser are we using, the default query parser or some other Dismax query parser, which will be covering all of them in detail. The query parser retrieves the information the way you want from the index and returns it to the response writer. A response writer is nothing but based on what you have configured, it will return either XML response or JSON response or any other binary format response. So this is the very high level flow what happens inside the Solr search process. Okay, apart from Lucene features, Solr also has a little bit more features like more like this, suggesters, transforming, all of them. So this is the list of things which we'll be covering in our course. I just listed out few of them, maybe not a very extensive list. So we'll be covering it out, everything in detail. Great. So we said we will be handling all the configurations or all the control aspects of Solr through configuration files. So Solr config.xml is the one which defines the components of the search and the indexing part of it, right? And schema.xml handles all this field type definitions, what kind of field your documents has, very loosely defined structure where you can say this is the structure of my instance. Okay, Solr.xml defines at the server level, it defines how many indexes or cores do I have, okay, where is it storing all the data, kind of thing. Core.properties is related to a particular core, all the properties defined to it. So Praveen says Java coding is required, or is it tool to build code? Okay, so if I understand, for using Solr you don't have to know Java. It is a RESTful API where you can access all the content and index all the content using HTTP requests. So you don't have to know Java code for it. Fine. So this is one of the significant changes where the Solr is going to take the search databases into a different dimension altogether. So using Solr's cloud technology or architecture, it can serve the distributed needs of enterprise applications. You can have multiple clusters. So someone was asking, can I use HDFS? So you don't have to use HDFS because Solr Cloud itself is a distributed architecture which can store the data in a distributed fashion. So we'll be covering all those things, how the nodes, so similar to if someone is very familiar with Hadoop, you can see how to handle nodes, how to handle replications, how to handle failures. These are all the key aspects which someone would worry you of. So Solr Cloud provides you all these things to scale horizontally or to scale elastically, where if you have to keep only few servers during few months of your application runtime, so Solr can scale, Solr Cloud can scale elastically and horizontally, also providing high availability for failover, high availability for reads and updates, and also it is supporting distributed index and searching. When I say distributed, you don't have to store all the records in one server. So the records are chucked off into pieces and distributed across the servers, and you can retrieve those information in a much more efficient way. Apart from that, Solr Cloud has all the features of managing the cluster, doing the load balancing, failovers, integration, and the configuration management aspects of it, which we'll be covering in detail. Okay, just to give a high-level overview or the nutshell of what the architecture is all about. So this is the glimpse of it. You can have multiple servers. Each server can have piece of the information or the sharded information and replicas of the data storage in the distributed architecture. And there can be a leader which decides which piece of the information has to reside on which server. So the leader is elected by the nomination or the nominated or the designated by the zookeeper. So if the leader dies, the zookeeper decides which the next leader has to be selected randomly, and then that leader decides which piece of information has to reside where and how to distribute the reads or how to distribute the rights. So all this is part of the Solar Cloud architecture, which provides you the distributed nature of the solar architecture. Okay, fine. So I think I extended or stretched a little bit, another 15 minutes. So this is a very hypothetical representation of what could be the job trends or what has been the job trends. I potentially see, rather not worrying about job, this is a very beautiful skill to have on my tool list, and I can explore or do wonders. Instead of going and searching for a job and then trying to learn a skill, I will try to keep the skill in handy and try to push the skill wherever is applicable and demonstrate and showcase it in all the places. So that would be my approach. Okay, fine. So I don't think I have got a lot of time to do this, but still, since I wanted you guys to see, by end of the course, you should be able to build an application, something similar to this, and get it certified from Edureka. So if you notice, there is a lot of, so this is the autocomplete. So if you submit, you should be able to see all the Samsung records. Okay, by end of this course, using Lucene and Solar, you'll be building application something similar to this. Okay, so if you notice, these are the facets what I was calling. So in Samsung Electronics, there is one item you can filter, and you can see there is in the hard drive category there is one. So this is the faceting aspect of it. Okay, so also the price range, range facets, what we call it as price filtering. I can see all these aspects. So this is not a very rich UI application. So end of this course or after completing this course, you should be in a position to build applications of this grade. So that is the intent of the Apache Solar course. So maybe I can just quickly keep another 5 minutes or a couple of minutes for any quick Q&A, not more than 2-3, so that we can close this session. Please go ahead and type in your questions. Okay, Surendra says, is this UI provided by Solar? This is a dummy UI which comes with part of the Solar UI, but we will be building similar but a little bit more robust UI and services using Solar as part of our project. So Sam says, can Solar do any real-time scoring? Yes. So as I mentioned, scoring happens at two phases. One you can do at the query time and the index time. So when you do a Solar scoring at the query time, the score has to be provided at the query time, and the scoring has to happen each and every time the query has been run. Yes, it can do real-time scoring in that aspect. Okay, that's an interesting question. What are the other products like this? So there are very few in the market. Like Elasticsearch is again another similar product which is again built on top of Lucene, and also Solar is another alternative. So as per my understanding, Solar is the much more popular one. Yes, so as I mentioned, Solar is nothing but it extends Lucene, and Lucene provides a SQL kind of a Lucene syntax query. I'll show you exactly here. Okay, so here this is the query or syntax what I'm using. Okay, name, okay, equals iPod or features equals, this is the syntax, okay. I don't know if something like that exists. I'm just writing the syntax. See, I got the results. So what did I search? Features, I searched for HD, right? Is there a HD somewhere here? It should be. Venkat says, do we cover Solar admin in this course? Means installation and other admin things, or just, yeah, we'll be covering the Solar administration in brief, but if you notice, that is more than sufficient to handle most of your basic needs. If you are looking for a more elaborate troubleshooting, it might be a different course altogether, but as per my understanding, Solar is a much more simpler way to manage. We'll be covering the entire administrative screen in a bigger portion of the module, and you should be able to cover most of the administrative aspects of it. Okay. Fine. So maybe I think we should just close this. It's been more than what I thought it would be. Thank you guys. Thanks for stopping by, and it was really nice. I hope you guys are all enjoyed it. So please don't forget to provide your feedback. Since this is a new course, it would be always valuable for us to take your feedback and incorporate the same into it. Thank you everyone, guys. See you soon. We will catch up. Yeah, we'll catch up soon, and we'll cover anything left out in our further classes. Okay, thank you guys. Bye.